Hello, in this video today, we're going to be showing you how you can use object-oriented programming to train a malaria data set where we are going to be using an African data set with respect to malaria. So if you're a beginner to machine learning or you're somebody who is interested in data sciences and you're thinking about getting started with machine learning, then this is the right video for you. So everything we're going to be doing on this video is going to be practical. We're going to be using object-oriented programming. Everything we're going to be doing is going to be packed in classes. And essentially, that's what we're going to be doing to get started today. Now, I'm going to be using VS Studio Code. That's the environment that I'm going to be using. And I could just kind of come here, go to folder, and of course, we have to head into just kind of create a directory, where I'm definitely going to save all of my code. And yeah, I'm going to say pro tree ML. Okay, so I'm going to just save that. And automatically it's going to let me save all. And yeah, take me out of that. So we're going to be getting started today. The first thing I'm going to do is I'm going to create a file name. So I'm going to call this malaria. I'm just going to call it malaria.interactive Python notebook. And of course, I will choose the environment where I'm going to be writing this code, Python 3.13.3. Now, in this video today, we're going to be we're going to be using object-oriented programming. So I'm just going to kind of note that down. Object-oriented programming for machine learning using an African malaria data set. Okay, so that's what we're going to be doing. And of course, when we look at this particular data set, we'll definitely be the ones to create our classes, not just our class, our targets variable, okay? But we'll talk about that when we get there. So the first thing I'm going to do is I already have some of my dependencies installed. You could just come here and do pip install numpy pandas matplotlib and scaling and all of that. Okay, so immediately I run this. Oh, sorry, what's the issue? Okay, it could do pip3. Also do pip3 install. That's going to work. Or you could do Python. Could also do Python. Install, of course, that's definitely going to work. Okay. Now I'm going to close this and I'm also going to open my terminal here. I'm just going to open the command line. That's also another, another environment where you can install some of your dependencies. Of course, definitely it's going to work. I just want to be sure my PowerShell is trying to launch. So, of course, it's definitely going to work. Okay. Okay. All right. So I think we are good now. I'm just going to kind of close this. Okay. So I have all my libraries installed and I'm going to kind of launch them now. So I'll start with import pandas as pd, import numpy as np. Then I'm going to import matplotlib.pyplot as plt. Then also we're going to from sklearn.model selection. Okay, so we're going to import the train test split. We're going to import the grid search series, the SK, that's the stratified K fold. And yeah, I think that those are actually what we might need. And maybe we might actually need a cross-validate method as well. So that's that. So from sklearn.compose, we're going to import the column transformer from sklearn.pipeline. We're going to import pipeline from sklearn. Now this time around, we're going to go to there's pre-processing. We're going to import one hot encoder and standard scale. Okay. Then we're going to be working with the random forest classifier. Okay, sorry, that's going to be import random forest classifier, and then based on the metrics for us to check how our model is performing, we're going to import the accuracy score. Also, we're going to import the precision score, and of course, the record score, F1 score, confusion matrix, and also classification report. Okay. So basically some of this is definitely what we're going to do. So we're going to run that just to be sure everything works really well. Okay. So we're going to create a blueprint. So we're going to call this class malaria model. And of course, we're going to define the instance. So we're going to start with init. So how this is actually what we're using to initiate each time we instantiate this particular blueprint or object, an object of it. If we want to create an object of this particular blueprint, we're going to pass in all the parameters we're having. So we have self, I'm going to have phi path, okay? And then the next we're going to do now is we're going to say self dot phi path is definitely equals to what? Phi path. And then we're going to have self.df is equals to, now we can actually decide to load our data frame. So we're going to say, we'll create another method here to say, we're going to call this method load data frame, okay. It's going to take in self, and of course that's what it's going to take in. And we're going to say, of course, we are going to see. So I think it's going to maybe take 5 parts. No, we can pass that inside. So we're going to say self.df is equals to pd.read CSV. Then we pass self.5path. Okay, so this is kind of an instance. So each time we kind of run this object, it's definitely going to let us have our data frame. All right. I think that's just going to be that. We can actually print, loading our data frame, and then I'm just gonna put this, and then of course I'm gonna say print data frame. I'm gonna say kind of loaded successfully. Okay. So that's just basically that. The reason why we defined this here is because quite very important that we're going to use it, across this model. But best practice is that we can actually say self.df is equals to none. That's also very fine. And the next thing we're going to do right now after loading our data frame is to perform some kind of visualization. Okay, so we're going to take inspect data frame. So it's going to take in self, and of course we're going to print inspecting our data frame. That's kind of loading, and then we're going to print so So we're gonna actually print out this. We're gonna say, maybe we could just say to check the first head, or maybe to check the head of our data frame. Okay. So we're gonna we can print self.df.head. Okay. And of course, that is the df that was defined here. Yeah, so that's actually kind of best practice. So self.df.head, and we could just maybe check the first 10. And what else could we check? So we can actually see here, we'll see head is loaded successfully. We could also say self.df.info, kind of to get information about what this data frame is about. I think I'm kind of just going to print something here, kind of a comment, information about data frame. Okay, so this kind of tells us this is kind of data frame info. Okay, so this is definitely going to tell us like some particular insights about the data frame. So I think the next thing we can want to do is maybe kind of describe the data frame, and then we're going to kind of print data frame. That data frame now, this time around, now, this is kind of to get maybe the numerical, when we kind of use the describe method, we want to try to understand the numerical, how would I put it? I'm going to say kind of the numerical, summary that we can actually find the data frame. So maybe we could just say maybe self.df.describe. Okay, sorry, I think that's describe, and yeah. So what else? We could just want to kind of check null values. Maybe I could just come here to say print inspecting for null values summary. So we could just print self.df is null. Is null. We could kind of see is null dot sum. Okay. This kind of going to give us the summary and all of that. So I think basically when we run this particular method, it's going to kind of give us some insights. And also we're going to check for duplicates, and we can actually print self.df.is duplicate duplicates dot sum. This is going to kind of show us, what about duplicates. So I can actually show you something real quick here, so you can actually have an understanding. First thing I'm going to do is I'm going to kind of drag in this data set. So this is the data set. So let me just kind of show you what it looks like. So this is a comma separated value file. I'm just going to show you what this data set is all about. And so this is just it. Okay. And okay, I could just close that for you. And so this is what the data set looks like. And I just want to kind of show you something here real quick, because we are running this in classes. So I could just say something like maybe df, because it is a global space now. It's called pd.read. Maybe you could just put CSV, and then I'm going to pass in okay, so I'm going to say df. Of course, that's going to work. So I'm going to say df dot duplicates duplicated dot sum, okay, so that you understand what I'm saying. Summary, I'm going to actually assign that to a variable, and I'm going to kind of say print summary. Oh, sorry, I think I made a mistake there. I didn't kind of spell it. Okay. So this is what it is, summary, that's going to be 0. So basically that's exactly what we did here, okay? To check if there are duplicates inside of it, okay? I just wanted to kind of explain that. So I'm going to just put this as a comment. I'm just going to comment this out. Now, we continue with our class. Now, the next thing we're going to do right now is after we're done with checking for duplicates, then I'm going to print data set inspected successfully, okay? All right. The next one we're going to do, we're going to create another method. And this time around, first of all, we're going to call it clean data, okay? Cleaning the data. So more like we'll remove non-values because we could also want to check, we could also want to add maybe to inspect to see, maybe we could say print so that's we're going to say checking non-values, okay? And of course, I'm just going to be sure this is on the next line. And so I'm going to print self.df dot is now, then we're going to say dot sum, okay? So I'm also going to show you this again with our data frame outside of this class. Of course, I'm going to take out that. I'm going to kind of run this. And if I kind of change this to is now, and also uncomment this and print, oh, sorry. I think that was a mistake in indenting. Okay, so you see it gives us a kind of summary of the non-values, okay? All right, so I'm just gonna kind of comment this out, and all right, so something I'm gonna do here. This is the reason why I'm doing this is so that you guys can really understand how this works even outside of the classes, okay? So after that, then it's now going to check duplicates, which is the last one. So here we're going to actually perform our cleaning. So it's going to take self as usual, and because it's one of the methods. And what we're going to do right here now is we're going to say, okay, to clean, the first thing we're going to do is we'll need to remove the non-values, right? Then after we are done removing the non-values, we're going to drop duplicates and all of that. So self.df, now remember, I could do df is equals to self.df here, okay? And the reason why I'm doing this is so that I can be able to maybe use some kind of shorter, like I can reassign this inside of this variable, and definitely instead of this local, method space for this function. And then of course, reuse it, okay? Yeah, very, very, very possible for me. So what I'm going to do right now is I'm going to show you something right now. And so I'm not gonna do, so what I'm gonna do now is we're gonna say, okay, to clean the data. So where are we gonna start from? Of course, we could start by okay. So we could start by dropping duplicates. So say we're gonna print uh data. So I'm just gonna add a comment here. Code is available in my Git repository. Data cleaning, okay. Then I'm gonna say print removing duplicates in case there is any kind of trying to handle that, right? So instead of this method, we're gonna print kind of say self.df is equals to self.df dot drop duplicates. Okay. I just want to come be sure drop duplicate. I think that comes with the function call. And so, okay. And then we're kind of print removing maybe kind of cleaning up non-values. Now, there's two things are involved. I could decide to drop non-values generally, but then I could still decide to say, okay, I could decide to say, okay, instead of dropping the non-values, let us replace all the non-values with kind of fill it up, right? So let me kind of give you an example right now. So if you look at this data set right now, what I want to do now is if you come under this particular column here, you see that there are a lot of missing values here. Okay, from here to I think if I can highlight that correctly, you see that there are missing values here, there are missing values here, there are missing values here, there are missing values here. There are lots of missing values here. Same here as well. Same here. And also you could find some missing values, a lot of them. So the reason why I'm saying that is that if we want to do that, is we want to do some kind of forward fill, right? Such that we're going to fill these non-values, like if we kind of check out, use the forward fill. So it means that for this particular space from here to here is going to be replaced with 18. From here to here is going to be replaced with 6. And I'm also going to add the backward fill where we're going to also fill. You can see we've done just that. I'm going to stop that. And then also backward too, we can use maybe backward 18, because in this case now, if it just does it in a forward fill, then we'll see that there's definitely going to be some kind of empty columns, empty rows rather, that's particular at the top that doesn't have a non-value, okay? That doesn't have a real-time value, sorry. That's the point. So there are actually a lot of approaches to this. We could decide to say, okay, I want to use maybe the mean approach, then probably target specific columns, then cleaning it up with mean. Or basically, we could say, okay, yeah, we don't want to use the mean. We want to say, okay, let us use maybe another kind of strategy, right, to clean that up. Maybe drop all of them entirely or whatever. So, but that's not actually what we're going to be doing right now, because kind of just want to keep it very simple. So what I'm going to do right now is cleaning up the non-values now. I'm going to say, okay, so for us to get rid of the non-values, we're going to say, okay, now let us do some kind of maybe self.df. So it's going to be equal to self.df dot now fill now values dot I'm gonna use some kind of stuff like maybe so we're gonna kind of fill now with method of, maybe you could see maybe forward fill, and we could say dot maybe fill now with a method of equal to maybe a method of backward fill. I'm gonna run that. Okay. So of course that should work really well. Yeah, that should work very well without any issues. So I'm just gonna open this up so that it can be easier for us to have this kind of completion. So say does fill. I see that's coming out because we have some of this running. Basically that's what we're gonna do. And now the next thing we're gonna do after we fill the NA is we can I'm kind of just gonna write something here. I'm gonna say, okay, no, not that. So I'm gonna say here. I just want to make sure this is indented properly. We're gonna kind of print filling the non-values. So just don't get me wrong, there are actually other ways you can use in handling non-values in C, or no, this nice in Python. That for machine learning, okay? So this is more actually of pandas insights from pandas tutorial, okay? Then the next thing we're gonna do right now is so since we have self.df is equals to self.df.fill any method and that, we've got that field, so we can decide to say, okay, we've removed some non-values, we've dropped duplicates. Of course, our data set is now kind of getting a shape. Or maybe we move on to kind of create another method, and we're gonna call this, this time around, we're gonna say handle columns, okay? So we're gonna pass self, and so instead of this, I'm gonna say self.df.columns. So it's equals to self.df.columns. Kind of show us some stuff. And this time around, I'm gonna say dots as type string. But I feel like the first thing we might do might be to rename it, right? So we could say self.df, self.df dot self.df is equals to df dot self.df, okay, dot rename, and then I'm gonna say something like columns is equals to. Now, how are we going to be able to get these column names? What we might do is we could just come down here to see, maybe kind of create call that object, right? So let's just kind of create an instance so I can be able to visualize that. So as I'm going to say passing ML malaria dot, then I'll pass the file part so that I can be able to see that. So that's what I'm going to do. So I'm gonna assume that maybe you're just kind of programming and maybe you don't have access to that. So I'm gonna kind of say maybe ML is equals to malaria. And then I'm gonna pass in that data set, and I'm gonna say ML dot uh ML dot the load data frame and the load data. So can I check it, load data frame, and yeah. Of course, data frame has been loaded, and of course we could just we don't need to inspect. We just go straight to clean. And how do we actually visualize that? We can see something like uh, data frame has been loaded. Of course, we need to create an object for that. So we could see df of maybe view uh, df. I could just kind of try something, columns, self, and of course I could see maybe could say just return self.df dot columns. Yeah, of course that's what I'm gonna do just to show you how that works. I could say ml dot view df columns. Maybe I'm gonna say df is equals to this and df. Oh, has no attribute view. Okay, I didn't run this. I'll run it now. It should work. Okay, so that is just what it is. So these are actually kind of the column names. I'm just kind of showing how you can get that done quickly while you're still creating your class. Okay. Yeah. So you see how I created that object to view data frame columns. I could decide to ignore that maybe later on. So why did I do that is because I kind of want to rename them here. Probably handle that particular data frame. They are more like the data frame column that I've called. All right. So in this particular method here, what we are doing now is to rename this data frame, country name. We're gonna change that to country. Year is gonna be changed. No, I don't know. I typed there. I cannot think. Maybe I could just indent this inside a bit, and then yeah, there wasn't any issue with that. I'm going to call this code, and so we're going to change this. So we're going to do this real quick. You could set fast forward if you're watching this. Okay, so probably we don't really need to change this. We could decide to ignore. Uh, we could decide to ignore that, and of course, no issues with that. And yeah, so we can decide to ignore. But I feel like what we want to leave this here is so that we can be able to see. But regardless, even if we ignore, nothing is definitely going to happen and all of that. Okay, so excuse me. Uh, so that's just basically that, guys. We can handle our columns, but then we can actually decide to, properly arrange them. Here we could say maybe dots, dot string, dot strip, and then I have dot string, dot lower, dot string, dot replace. I think basically we have actually addressed all of that. Or maybe if we're gonna have some space, I'll take it to underscore, and then let's have regex equals to false. What's the issue with that lining? Kind of be sure of what we're doing. We're in the right indentation. And okay, I think okay, there's a comma. Yeah. So this is to handle our maybe our column names. Our column names, kind of I would say normalize, but I would say kind of text. You know, handle the text, okay? And okay. I think we can actually kind of delete some, just maybe we could just leave that other one there, but yeah. So yeah, that's just that. So this is definitely how I'm gonna handle our columns in Python programming. So I'm gonna say this is kind of uh maybe here I'm gonna say renaming our column names. Okay, so I'm gonna print renaming our column names for volume and kind of add there and I say, okay, that's successful. I'll just be sure I'm on the line. I'm in the right programming line. I'm going to say kind of print renamed successfully. Okay, so that's fine. So, but then this is just to handle our column names, but then, that we could also add other params here, but essentially we've just kind of renamed it and handled it properly. So this is what we do in pandas. What else do we need? We might want to drop some columns. I don't know if we should have a method for that specially. Probably to drop some columns. We could just do like def of maybe I think we can actually can call this handle columns. Uh yeah, so handling columns, of course, so we can drop, so I can try to say uh self dot. So I'm gonna say dropping the irrelevant columns. Okay, so I'm gonna say print about to drop the irrelevant columns, and we're gonna say self.df is equals to self.df dot drop, and columns is gonna be equal to. So there are a lot of columns different. We're not going to be interested in country name. So that became country. So of course we'll have to drop that. And what else do we need to drop? Yeah, I don't think we'll have any business with that. So I'm gonna drop yeah. And what else are we dropping? We're also dropping. Okay, I think this is actually what we're gonna be dropping, okay? So remember, guys, what we did here is dot fill any method forward fill and fill it. So can start to actually say method equals to mean is going to work. It's still going to work. I could say df dot fill NA with df dot mean. Now, but the issue with that is that if we have some kind of categorical variables, is going to drop them. Okay, it's going to drop them. It's good. It's more like it's not going to do anything. Then what I mean by that is that, let's say, for example, we have variables that are in maybe something like sex, male, female, and all of that. So it's going to be very difficult to handle that. Okay. All right. So I just want to kind of go through this for just a moment. So, all right, guys. So we're back, and so yeah. So now looking at what we've done, renamed successfully. So we've dropped some kind of relevant columns. Just want to be sure there is any other kind of code that maybe we might not really want, but I think we are good. Now the next thing we might do now is to kind of create a target, right? So I'm going to say def to be sure I'm still here. Oh, I think I shifted inside a bit. Okay, so yes, I'm going to call this create uh, target. Okay. So I'm going to create targets. So this is our target, what our target is going to be, because right now almost we have X and Y. And yeah, of course we have kind of X and Y and all of that. So, but we need to actually know what is our target, okay? So it's going to take a self as usual. Then we're going to have self the target is equals to whatever, okay? For now, none. But then I don't think there's any need for this here, but what we are going to do now is I'm going to kind of nest a function. Because I need the reason to calculate my target. Because actually, when I looked at this data frame, uh, because the data set, I couldn't really find any way to uh, create arguments for my target. Like we have, use of site-treated net, we have malaria cases. But then I couldn't find like because I want to perform a classification. Remember what we're performing here is uh, a kind of classification based machine learning training, and we don't have that binary outcome. Not can say I mean as type int, then put in our just kind of get those column that we use for classification, maybe 0, 1, or maybe multi-classification 0, 1, 2, or 3, all of that. Okay. So we're not really performing kind of regression here. We can still do that. That's still possible. But for the sake of this video, actually, we're not really doing that. So what we're going to do right now is I'm going to kind of show you how we can get our own targets. So I'm going to create a function here, a nested function. So I'm going to say calculate risk, and then of course this is going to take in what criteria can I use? I could use maybe malaria cases and bed net. Okay, so that's what I'm going to use. Okay, so I'm just going to pass in malaria case, and I'm going to pass in bed net. Now, remember, this is a function, so this is just going to be a very short function. I'm going to say return one. I'm just going to say one. So I'm going to use a ternary, also one of my ternary operator. So return one if maybe malaria case is greater than maybe 100K, because I'm going to check this data set here, and we have 44,390. Oh, that's because you could just want to check um maybe you could just want to check, kind of describe this particular series, because it's just a single column and this single feature, then get the maybe the mean, and then now know how to maybe kind of the interquartile range, maybe 25% interquartile range, or 50% interquartile range, or 75%. Then maybe you could just strike from 50% interquartile range. I could just show you that real quickly. Let me just show you that, what I'm talking about. Maybe we could use this class that's outer of this function. So we'll see maybe something like df of that is going to be malaria case reported. So I could just maybe say df of maybe malaria case reported. Oh, sorry about that. I mistakenly touched the wrong thing. Dot describe. Just to be sure this is working, I'm going to load that, and so of course, if you look at the 75% interquartile range here, 0.154808, so can strike at 100, right? And that's E06, that's 100, that's 3. So yeah, that's where I can strike on maybe 5, whichever condition you want to use, but that's what I'm going to use. So I'm going to say if malaria case is greater than maybe 100,000, and maybe a bed net, just to be sure, is less than maybe, could say 60, 1 else 0. So this is what a ternary is. So each time we're going to use this function, it has to return 1 if it checks that this particular two categories in our data frame, and find the ones that have malaria greater than 100,000 and bed nest uses 60. So let me just kind of show you what that means here. Okay, so bed nest 1833, kind of go down, and you see some 61, 73, 66, 54. Yep, so there's that. So we could still put it at 50, that's not bad, and maybe 55. I think that works well. So this is less than, if it is less than 55, okay, so that means these guys are not really using insecticide treated net. And if it's greater than 100,000, then the cases, then that means we're trying to predict risk, okay? I could kind of make some modification here. I'm just going to say object-oriented programming for machine learning using African Malaria Dataset for risk prediction, okay? I'm going to simply add for risk prediction. Okay, so that's really works very well. I think that satisfies our claim, of course. So what we're going to do now is I'm going to create self.df, and then I'm going to call this malaria risk. Okay, so this is what I'm creating, a new target. So it's going to be equal to self.df.apply, and kind of going to pass a lambda function here, and I'm going to pass lambda r, and that's going to be what? That's going to be maybe calculate okay, I just like everything being this way. You're gonna say risk, go to uh this particular part of the data frame. So this time around, we're not going to use that function. We're probably going to use malaria risk and that malaria cases and then bednet use. So I'm just going to pass that here. And of course, I have, okay, I'm going to wrap it inside of a string. And what else? It has to go to bednet use, okay? And axis of 1. So I think that works very well. I think maybe I could just kind of comment some of these things out, okay? So that it's going to let us see our data frame and understand what we are doing. So that's that. So now what this means now is that we have our target. So our target self dot target is equal to malaria risk. So this is what our target is, okay? So we've created our target. So now next thing I'm going to do now is we might want to now start our pre-processing. And what we mean by pre-processing here now is that basically we want to now kind of check in some parts of our data frame, and then we get the numerical columns, get the cat columns and all of that. Okay, so what we can call this now is pre-processing. Maybe we want to say maybe prepare. I mean, we can say maybe data preparation, just kind of to know what our X and our Y is. So of course, it's going to take itself, and so kind of gonna print here. Maybe sorry, I'm gonna call this. I'm gonna print target with successfully. And let me kind of say here, I want to print target loading. So this is the function for the target. And then we have our function to create target list, target argument. And yeah, so that is definitely what that's going to be. And we have data preparation, then we have self.df. Now, so I feel like what we need to actually understand is that we need to know what's our numerical columns and category. But before then, we should know what our X and Y is. I'm going to say X is equals to uh, so what's going to be our X right now? It's going to be everything in our DF. Then we drop self.target. Okay, so that's going to be self.df.drop. Just to be sure there's no issues in our data frame again. Drop maybe columns, drop or could drop self dot target. Okay. And because this is now in the data frame, malaria risk is self dot target. And I just want to be sure. Okay, so we're dropping, and then so the target axis equal to 1, of course. And then we could say y is equals to, I think we can just call this self dot x and call this self dot y. And we're going to say self dot df of self dot target. Just to be sure this is working well, I'm sure that, and then we can now identify our columns. Then I was thinking if we can maybe kind of normalize our columns to remove some NaN, but more like we'll field that. So what we could do here now is splitting data. Okay, so we're gonna print data preparation started. Print data preparation done. Okay, so it could just print anything. So this is going to take I think that's self, and then splitting data is going to take in self. And then what we're going to do here now is we're going to say self.x first, x string, self.x test, uh, splitting data about to be done, self.y train, self.y is equals to train test split, self.x, self.y. Then we're going to have in our test size of 0 maybe 3, and then maybe random state of maybe 43, and then stratify equals to self.y. So kind of print train test split completed. Now, I think there are some other things we might want to do. Kind of think this is so we could just leave that for now. And then one thing I'm gonna do right now is so we're gonna try to create another method, and this time I'm gonna call this splitting data sets. Now we've created that. We're gonna call this now our. So we're gonna create our numerical column. So maybe we can call it further preprocessing self, and then I'm going to say num cause is equals to x self dot x dot select. Now, what we want to do right here now is we're trying to just kind of get our process self dot x select data types of maybe mm, so we're gonna select self.x, select data types. So what kind of data types do we want to select? We want to select probably kind of include, so we're gonna include int 64. I could just say include maybe you could say int 64 and float. Or maybe we could just, how about just int 64 and float 64 dot columns, and the categorical cause is going to be self dot x dot select data types include equal to object. Okay, so that is definitely what it's going to be, and I'm sure actually we are, getting that, you know, kind of, well done. And so actually here, another thing we can actually do here, we could just say maybe columns is equals to, then we just rather pass this here, just to be sure. And yeah, I think this is kind of a much more better convention, okay? Because of this. And now the next thing we're going to do now is kind of include this as an object. So we have dot columns, okay? And the next thing we might want to do now is, so we're going to kind of print. We'll start this by saying we want to print performing preprocessing. Maybe we could say maybe performing some kind of further preprocessing. You can say here, maybe you can say maybe print both category and numerical columns have been sorted. So this is a very, very important metrics here. And the reason why this is important here is because you don't want to kind of select, maybe start sorting them one by one. It can only have three types, three data types. Anything that is entered inside machine learning model can only have three data types. It can only have the int64, float, or this. Now, if you don't want to put this, another alternative you can do here now is just to say you can just remove this. Maybe if you have like kind of int32, you can just remove this and write numbers. Okay, maybe for example, I could just write here as numbers. Okay, so that's also going to work. Okay, but I think I actually prefer my code this way. Okay, so of course that runs no issue. I think we could just kind of take this out, so it doesn't really mess us up. And the next thing we're going to do now is we're going to actually define. We're going to kind of define our. What are we going to do now? Because we have our num columns. I think we're going to say self dot so that we can be able to use it in another self dot cat is equals to self dot x and all of that. So yeah, so we can be able to use it when we change further. And now we're going to perform some pipeline operation. And so I'm going to call this pre-processing. Okay. So I'm going to call this further pre-processing. Okay. So we've got the self and then so we're going to assume pass. For now, so we're going to create another one here. We're going to call it maybe column transformation. Okay. So kind of be faster with that. And then we're going to create another one here. We're going to, oh, sorry, we're just going to, yeah, I could pass. And then I'm going to create another one. I'm going to call this evaluate model self. I'm going to pass. Then, first of all, before we evaluate, I have to kind of def train model self. I'm going to pass. And yeah, so those are actually the thing. Then before we get to the last one, we're going to def tune model. And let's say self. So now we pass, okay? So I'm going to start from here now. So the next thing we might do here now is we can now say, okay, for that pre-processing. So yeah, so we have our numerical columns, we have our we have some sort of what would I say? Probably yeah, okay, I actually forgot something here also. We might do some after evaluating, we can do some maybe cross validation, self, and pass. So yeah. So what we're going to do right here now is that since we have ourselves the norm columns, so we're going to kind of fit this into a pipeline. Do you understand? And first of all, I'm going to say that self.numeric pipe is going to be equals to, we're going to use the standard scalar, and I'm going to say self dot maybe categorical pipe is going to be the one hot encoder, and yeah, let's handle unknown as ignore. Okay, so maybe oh sorry, I think I should indent, and I could just kind of print preprocessing for the model. Now I think guys, we are using an ensemble method, which is a tree-based method, and most tree-based methods doesn't really need scaling. But for the sake of this video, I'm just kind of going to be showing you that because I don't think standard scaling for randomized forest round, it makes any kind of sense. But of course, yeah, I don't think so. It does. So, but I'm going to do that. So I'm going to say self dot preprocessing preprocessor. I think that might be a much more better word. Preprocess. It's going to be equal to so maybe we can call this create create norm and cat column, cat and norm columns. Okay, don't mind me. I'm always fond of that. So I'm going to pass in the pipeline, and then I'm going to say steps is going to be equal to. Now here, this is where we're going to fit in our kind of preprocessor, and we're going to have this like num. So we will pass self dot numeric pipe, and then we'll pass in our self dot num calls, and then I think here we're going to have another one. We're going to say here cat. We're going to see maybe self dot categorical pipe, and then we'll have self dot what else I'm going to call this? Maybe we could call it maybe self dot cat calls, self dot cat calls. Okay, so that's fine. That works very well. Now, I think that is that column transformation. How did we get here? Column transformers. That is basically what will fit our model now. So we can call this load model. Okay. Also have to pass it through a column transformer. So we'll now say, okay. So what we're going to do now is we're going to say our model this time, because just to be sure. Okay, this is the first one. 10 steps. I think this is supposed to be the transformers. We might not really have anything to do with the pipeline. Okay, so I think this is this is supposed to be the column transformer. Okay, I think transformers is going to be this, and so this is basically so could still call this preprocessing. Okay, and code preprocessing and column transformation. Okay, so the mind me is better you have this. So preprocessing. So yeah, so of course we have this standard scale, all of them fitted here, and so we can pass it to transformers, and then we kind of load our model, and I was gonna say, so I could just say print preprocessing and column transformation successful. Okay, so the guys, the next thing I'm going to do now is I'm going to create a load our model. So I'm going to say our model, people say solve the model is going to be equal to, or maybe we'll call it log pipeline, or whichever thing we want to call it. We could call the model whatever thing that we want to call it, anything you want to call it. So I could call my self.model. Let's call it self.model and see what happens. Okay, so wherever we get to, we can try to change the name. Okay. So it's going to be the pipeline. Then we have our this self.random model. I think yeah, that's better. So we're gonna call this steps, and we'll have our kind of this time around here is going to be okay, no, this is going to be preprocessing, preprocessor. Okay, then we'll have solve dot preprocess, and then of course we're going to have a classifier, and then we'll have randomized forest classifier with an n estimators of maybe we could give it n estimators of maybe 100, n estimator of 100, and with a random state of 45. Could decide to do that, and of course definitely going to run, but quite very, 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 very nice to do and all of that. Okay. So guys, the next thing we are going to do right now is after we are done with our pre-processing is that's after we're done loading our model. So could say here, could say print loading model, print model loaded. I think we're gonna we probably could just pass in model dot now could say self dot solve the random model dot fit, and now passing self dot x train self dot y train. Okay, and I think yeah, this works. This still works, because if we return this, then it means automatically from here we'll start taking it in. But that's fine. Some of the model is equal to that. It should be equal to that. We have to just kind of and did we have a train model? Maybe we could just pass that to a class, to a method on its own. So could say define train model itself, and okay, so we're gonna print here. We're gonna say model about to be trained. So I'm kind of going to print here. I'm going to just come in and I'll print model trained successfully. Now, guys, there's something I'm going to do right now. Kind of going to come up here that I defined my target. And essentially, what I want to do now is to perform some kind of visualization, okay? Even if I'm going to perform some other ones later on, but I think it's quite going to be nice. In a particular here where I created my target, to perform that visualization. So I'm just going to kind of create a method here, and I'm going to call this method visualize, and it's going to take in the self keyword, and then I'm going to say self dot target, okay, dot plot, okay, dot plot kind is equals to bar. That's kind of work, df of so dot plot. So that's df of that dot plot kind equals to bar. If there's any other thing, maybe we could want to pass in, we could say maybe probably color is equals to blue. That works. And we're gonna say plot dot title. I'm going to say dot value counts. Yeah, I think that's going to work well. So we're going to plot the titles. We're going to say kind of distribution of maybe malaria risk. Okay, so plot.x label is going to be that is malaria versus zero equals to no risk, 1 equals to risk. Okay, then we can have plot dot y label. I want to call it the distribution. And plot dot maybe for y. Plot dot grid. That's gonna be false. We don't want to show that. Plot dot show. I think that's all. Okay, so this kind of some visualization, so we could just print about to perform some visualization and because print visualization done. So guys, if we actually want to still print out or that maybe kind of perform some visualization, maybe of maybe outliers and all of that, maybe plot dot box plots. Maybe we could do that for whichever part of the data frame that we're actually really much interested in. But for now, we are just kind of keen on maybe doing some just understanding how our target variable is being distributed. So that's why we're definitely going to run that. So we're going to try to continue here, training our model. We have self, and self.random.fit, X train, Y train, and so that's that. So the next thing we are going to do right now is we are going to now say, okay, since we've got this, we can now perform some evaluation, okay? Of course, we can perform some evaluation. And that's what we're going to perform right now. So to perform some evaluation right now, guys, what we're going to do basically is, so what are some of the key metrics? We talked about accuracy score, precision score, recall score, F1 score, and all of that. So we could just say print here, evaluation about to be performed, and so we're going to print, so what we're going to do right now is for evaluation, remember we're interested in probably we could start with our widespread is going to be self dot random model dot predict, and then we'll have self dot x test. Okay, so our y probar is going to be self dot random model dot predict probar self dot x test Now, but I feel like we're going to use this somewhere outside of this function. So can I use self.yprober inside of there? And guys, then the next one I'm going to do right now is we're going to kind of check what else we need because we'll have this. So we can now go to, maybe I could just kind of put a comment here. I could just say maybe for our accuracy. So to check the accuracy of the model, maybe kind of bring this in. So that's, so kind of do it for the accuracy. We're going to say arc is going to be equal to accuracy score. Then we'll say self dot y test self dot. So this is also going to be the same thing for kind of our precision. Okay, so I'm going to say precision scores and show our recall value. Kind of trying to drag that in. I'm going to call that recall. Okay. Now, we're also going to go for our ROC value. I'm not sure we imported that, so let me just come outside globally and say import. Okay, let me go up and import. Let's see is no. Can I just be sure that we also imported some? Maybe we have classification reports, so I'm going to say ROC, AUC score, and here we're going to pass in our cell.y test, cell.y prober. And so we could just easily print all of this. We could print our accuracy is definitely going to be the accuracy. Go print precision is definitely going to be precision. Recall is going to be going to print ROC AUC is going to be. Now, I want to tell you something, guys. So I'm going to kind of say print displaying the metrics. Now, the next thing we might want to do here now is that we can't just decide to gonna print evaluation done successfully. Okay. Is there another one that will come and we want to print maybe kind of classification reports? Could say classification reports of self.y test and self.y pred. So I'm going to call this class report. Okay. And I think we could just leave this out of a new line. Class I'm going to kind of use a bold. So, and we're going to try to give it a new line and going to pass in class. And with nothing. Okay, so that is going to be that, guys. I don't think there's really much to do. This is just it, and then we can actually now say maybe kind of display ROC curve. Also, we're gonna for that, we're gonna pass in self, and now what's this gonna take in now is gonna be TPR, FPR rather, TPR underscore. I just want to be sure we imported ROC curve, so I'm gonna add it here, ROC curve display. Okay. All right, so what we're going to do right now is we're going to have kind of TPR underscore is definitely going to be equal to ROC curve, and then we'll pass in our self dot y test and self dot y probe. Okay. Now what we're going to do in this function now is we're going to say plot dot plot dot plot, and because it's definitely a line plot, so we're going to pass in FPR, TPR, and I'm gonna have a label. Label is gonna be, maybe we use an F string to say, yeah, our ROC AUC is gonna be equal to, then passing our so we could say self dot ROC, and then I think that should work fine. That should work, okay? Now, but alternatively, if we want to keep our code clean, what we can still do, is we can still decide to say our ROC AUC score, and then we're passing our self.y tests and self.y probe. Okay, so I could wrap this with a round, or rather we could just say .2f. That's fine. Into this map place instead of passing the round function then. So what we need is plot.plot, and then we're gonna pass in 0, 1, and 0, 1 line, and the line style. Okay. Plot.x label is going to be the false positive rate, and plot.y label is going to be the, kind of took me away. I don't know what I was doing. This is true positive rate. We're going to have plot.legend, of course, plot.read. It is going to be true. And how we plot.title. Plot.title, could see RC curve. Illustration from what are we gonna call this thing? For malaria risk prediction from an African data set. Sure. So guys, what we're gonna do now is this cross validation. So I'm gonna say self.cv is equals to of course self.cv is going to be our stratified key food, and then we're gonna pass in an n split at 5, and we could use a shuffle through random state at 45. Okay, scoring here. We could say self.scoring. Let me self.scoring is equals to accuracy, and then we have accuracy F1, F1, precision, so guys, this is what it is. And for you to perform this cross validation and also kind of print some result from it, could just say print, uh, see, uh, CV results is going to be, call the cross validate method, and then we passing self.random model, and then we're going to pass in self.x, self.y, and then we're going to pass in CV is equals to self.cv, scoring is equals to self.scoring, and I'm going to say return and score as false. Okay, so to print the results, so we could just see here, want to kind of display the results of the training, no, of the test score. So we want to of the test score based on the metrics. So kind of saying our accuracy, right? Our goal of accuracy. Okay, I'm just gonna kind of note that. Okay, there's no need of saying that. So kind of wrap everything in the print function. So I'm going to say print accuracy. That's going to be this is the accuracy, right? So we're gonna get the test accuracy after cross validation. So the test accuracy. Maybe I'm gonna just put that there so beginners can understand following cross validation. If you want to add extra, I could say the mean test accuracy following cross validation. That's going to be what's actually better than together? Okay, that's too fine. Maybe you could say CV, because this returns a dictionary, and then instead of it is test accuracy. Okay, wait, dot mean. So this is definitely going to loop around and get for. It's just going to go get this index that's the test accuracy, because to return train score is already false. Can I maybe print another thing there? I could just duplicate all of this. I could duplicate it and mean and this is going to be what am I going to call this now? I'm going to call this F1 score. I'm going to say test of. So I'm going to call this RC AUC. And so that is that. And I'm going to print. So guys, that's the last thing I'm going to do now is to tune our model. That's not really difficult to do. So could I say param grade? Uh, so inside of param grade, we could say maybe uh, you have classifier underscore underscore. The first parameter we need to have is definitely we kind of an estimator and of course we can have we can have 50 or 100, which one know which of them which is better, and we can have classifier underscore underscore. Then the next one we'll have is max depth, okay? Max depth. I could use a loop to do maybe I for I in range of 10, okay? Just to know which is the max depth. Because basically if you have this, done outside this class, let me show you what it means. I say norm is equals to this print norm, okay? So it's just going to print numbers within this range, okay? But if I want it to be between the range of 2 and 11, of course, it's going to get it from 2 and 11. That is how it works. So I could just do the same thing here between the range of 2 and 11, just for it to give me that kind of shortcut there. So I'm going to say grid, or maybe self.grid. If I'm going to use this outside here, I'm sure I'm definitely going to do that. Self.grid is equals to grid search CV. And of course, we're going to have grid search CV. We're going to have self.log random model. Okay. I want to be sure I'm on that part. Self.random model. And also we're going to have a param grade is going to be equal to param, of course, is equal to param grade. And before scoring, we're going to say self.scoring. I can say scoring is equal to for self dot, no, that's not scoring. We're going to say CV is equals to self.cv. Okay. And then we could say scoring is equals to maybe accuracy. Oh, okay. I want to know what is. Okay, there is no comma here. All right, so these are actually all the parameters that I've entered inside of this. So we can actually have maybe self.read.fit, and then we're passing x, self.xtrain, self.y train. Now, guys, what we can do here now is we can say yes, tune get best uh tune best params. I'm gonna take a self as usual. So I could just come and print maybe kind of hyper parameter tuning and print maybe hyper parameters tuned. It has been tuned. So for this particular method here, of course, it's going to take in. So it's going to take in self dot. Now, what we want to print here now is I can just say print best params is now going to be grid self.grid self.grid dot best params. Now, to get this is for the best parameter. So I'm going to call this function get, okay? So I'm going to call this now here is getting the best parameters, okay? So that's what it is. And here I'm going to call this getting the best accuracy. So here I'm going to kind of print best accuracy is going to be read.best score. If that is that, just to be sure, we could just run this and run this. Best score, I guess that still has an underscore there, but so we're gonna call it new tuned prediction. It's gonna take in self, and what we're gonna do now is I'm gonna say self dot best model is equals to self dot grid dot best estimator. Okay, that is what it should be. Could just say maybe that's quite going to take a lot of time, just to experiment that with that because so we're going to have Y-tuned. There's no need of, there's no need, we could just Y-tuned spread is going to be equals to self.grid self.best model self.x test. Okay. So we're gonna call this y-tuned, sorry, we're gonna call the y-tuned prober is going to be this. Dot predict. So here we're gonna add dot predict. And then of course, its probability. And what we can have, maybe we can just see, maybe we can add this self. We could also add here another self. I'm sure definitely we're going to debug. Of course, that's certain. We're not sure yet. But so we're going to say, okay, since we have self.best model, our self.grid best estimator, self.whiten bread, and all of that. So what we can do right now is we can say, okay, let us now pass and get our metrics, okay? So we can just print some metrics here. So let's print uh print new tuned uh new tuned params. So I'm gonna say kind of print params spread and proper set, okay? I'm gonna create another method, and this time I'm gonna call this a new tuned uh evaluate, okay? Self, okay, print new tuned evaluation metrics, and then I'm gonna print. Now, I don't know about just printing, so I could just print still. I'm gonna print the accuracy. That's the new accuracy. It's gonna be accuracy score, and then I'm gonna pass in self dot y test, of course, and then self dot y tuned spread. And I'm gonna kind of print in precision. I'm gonna have kind of precision score. I'm gonna pass in self dot y test, and I'm gonna self dot y tuned spread. Okay. Now I'll print the recall. I don't know if I actually imported that matrix. I'm gonna kind of say the course. Okay, I did a self.y test, and then self.y tuned thread. Kind of print the classification report. Okay, and that's going to be the classification report method, and I'm going to pass in self.y test, and then self.y tuned spread, okay? Oh, I guess we forgot to print the confusion metrics. I'm just kind of remembering that now, so kind of gonna add that somewhere here before we run our method. I'm gonna say maybe confuse is equals to confusion matrix and pass out dot y tests. I don't know if I spelled that correctly. So the y test self dot was okay. So could just print that here. Could just print it somewhere here. Could just print confusion matrix. So we're gonna just kind of add a backslash, a new line there. So kind of confused. So yeah, that is that. And also, what else are we missing out on here? We need to have we need to have what we call we need to we have classification report and yeah, okay, we have classification report, we have recall, we have precision, kind of confusion, matrix, and gonna call that confusion matrix. Then we're gonna say self.y test, excuse me, and self.y tuned prep. I think, okay. Yeah, so the next thing I'm gonna print here is our, maybe we could just get our tuned ROC now, so call it tuned ROC. So I could call this the tuned accuracy, tuned precision, tuned recall, tuned classification. So we want to kind of make some kind of comparison, between what we've done and this. So we're going to call this tuned ROC. Trying to check ROC AS score. Also the Y test. Self dot Y tuned probe. Okay, I think that works fine. So we're gonna print new tuned metrics successfully gotten. And I think, sorry, I don't know. And I think that's fine. Maybe we could just add it this and second. This, I mean, kind of some documentation. The new tuned metrics. Okay, I think that's fine. Oh, sorry, I don't know what I wanted to kind of save this file. I have to save it. Okay. So guys, we are good right now. Maybe we could just add another method. Then we're gonna call this the tuned ROC, okay? That's the tuned ROC. It's gonna take itself and it's gonna print. We're gonna say, okay, getting the new ROC curve. Okay, I'm sorry about that. It was quite much, but I think we'll deal with that. Then what we can see now is can see our new FPR. There's no need of using self because this is not we're not using it in any other part of this method. TPR, and then we're gonna underscore, we're gonna underscore, we're gonna say, sorry, this is gonna be equal to, this is TPR, new TPR, comma, then we're gonna underscore is equal to, okay, so we could just call this our threshold, right? So ROC curve, and then we're gonna pass in our self.y test. I'm gonna pass in our self.y tuned probe. Okay, and so could just say plot dot figure, could pass the fixed size as 9 of 7, and then we'll say plot, then we'll have our new FPR, new TPR, and label is equals to, RSC is going to be equal to the RSC AUC score of self dot Y test self dot. No, this is going to be self dot Y turned prober. Okay, it's going to be self Y turned prober and a dot to F. Okay. Then I'm gonna plot dot plot, and then we're gonna pass in 0, 1. So we can have straight line 0, 1. Line style is equals to, okay, plot dot title, we're gonna call it the new tuned ROC AUC curve for malaria risk prediction. Okay, plot dot X label. False positive with plot dot Y label. Okay, plot dot. So the next one we're gonna have here is plot dot problem plot dot legend, of course. So we can see the colors, got plot. So we can try to actually plot all of them together. That will still work. It's definitely gonna work. Yeah, of course. But that means we have to actually assign self to that one because it has to run inside of this function method. So plot dot show, I'm going to do plot dot read. I'm going to say true. And I think there is, we could just do maybe kind of plot dot y lim, and we'll set it at 0, 1, and plot dot x lim, we'll set it at 0, 1. So we don't have our plot overstretching. I think that is does that. I think if we want to have any other method now, we could say maybe print plot Newton plot split success fully. And maybe if we want to kind of perform some prediction, predict, and can say self. Now, what we can do here is before we perform prediction, we can save our model, right? So save model is gonna take in self. Okay, so we can say I'm not sure we imported job lib. I just want to be sure we did import that. Okay, just kind of check. What's it? Import. I'm just gonna bring it down. Import job lib. All right, so what we can do now is we can kind of save our model, and to save that we could say job we could say model, maybe we could give it self dot, maybe self dot what can we call it now? We could say job lib dot dump, then we're passing our self dot. What did we save that with? We called it our best model, right? We said best, self the best model. Okay. So that's best model. Then we're gonna call it random forest tuned model for malaria risk prediction. I think this model can be used in industry and kind of. So we can just put that there and I think that's pico. Okay. Of course, we're gonna print model saved successfully. Yeah, so see, getting ready to save model. Could still wrap this in a print statement. So that when our okay, so model save. Now, how about want to load our model? So could say load model self, and we're gonna pass in self dot loaded model is equals to joblib dot load um so we're gonna call this saved. Okay, so okay, okay, so we're going to say joblib dot load uh self dot loaded model is equals to joblib dot load save, let's say self dot saved model. Okay, of course, we're gonna print loading model. So maybe we could comment to print model loaded successfully. Okay, so now for us to perform some kind of prediction, we're gonna print prediction for model prediction using loaded model and and then we're gonna now say okay, print. We're gonna say sample state because we're trying to predict region now. Okay, we're not working with patients. Sample state is equals to uh self dot self dot loaded model dot predict self dot x and dot I lock I no zero. Maybe it's gonna be wrapped inside of a zero. And maybe we could make this 5. So we're gonna print maybe we don't need to print, I'm gonna say malaria risk prediction is going to be equal to um, so this is what it's supposed to be. This is kind of one of the data, part of the data set, and then we're going to have this dot predict sample state. Okay, yeah, predict and probability. So can now have improbable. Okay, so can now have solved loaded. Okay, so for us to now print, so now let's get there. Okay, so we're now going to so it's going to be malaria risk prediction, and we're going to also print probability. Okay, and that's that. So that's that. So we have everything done. We have performed our prediction and all of that. So we're going to run our code. So I'm just going to give you some time to take your time. You can just slow down the video, go through what I've written, uh, understand the code, and I'm just going to give you like maybe a minute for you to go through that and try and, you know, get some insights from the code before we run all the methods. All right, so guys, I'm sure we have gone through that and kind of give us some time to check out some of the coding, basically some of the things that I've outlined for you from the beginning to the end. Now, what we're going to do right now is that we're going to kind of run all of them and then, yeah, basically, you know, watch our results and of course, go through that, okay? Now, you can actually find out that I'm not using the Jupyter notebook to separate the kernel, but regardless, we have everything, well sorted and properly in line. So, to do that, what I'm going to do right now is, of course, we have our our malaria model here, and we have our load data frame, inspect, and all of that. So I'm going to kind of run them one by one so we can actually get it done. So the first thing I'm going to do is I'm going to create an object of this class because this object cannot run. This class cannot run if we don't create an object of it, okay? Yeah, so the first thing here is you could remember at the early start of this video, about 2 or 3 hours ago, I first started by instantiating this model, where I created ML, DF, and I loaded that. And of course, it returned this for me. So essentially what I'm going to do right now is I'm going to kind of so what I'm going to do right now is so I'm going to kind of go through them one by one just to give you some kind of heads up on what's running on the code, okay? Both front and behind the code. So I don't know why my monitor just the same to kind of minimize this a bit. Uh, okay, so I'm gonna just gonna minimize this a bit so that you can be able to, see what I'm doing. So we're gonna call malaria first, then load data frame second, inspect third. So you're gonna see here, I did call that. I'm gonna take out DF and so the first one. So we're gonna go back to start from the scratch. I'm gonna be going up and coming down. So load data frame, then inspect data frame. Okay, all separated with underscore. So load data frame, we're gonna say ml dot inspect data frame and kind of go up again. Then clean data, we'll see. So we're gonna call this ml dot clean data. We don't really need this function, so I'm going to skip this particular method. Okay, I did it then because I wanted to. So ml.clean data. So we don't really need this. So I'm going to comment that out. So yeah, and then we go up. So that means our data has been cleaned. Then the next thing is undo columns. So we're going to after undo columns, then we'll get to after handling our columns, of course, it has to lead us to create targets. So we're going to go to ml.handle columns. ml.handle columns, ml.create target. Okay, so we go up and that is to create target. So what we're going to do now is after creating targets, the next thing there should be visualize. So let's run this first of all before so we'll know that we are good with this. Okay, so we're gonna run that. Of course, it runs well. It says malaria risk is not defined. Okay. I will go up there to check it out. That was on create target. Okay. Sorry. We should have wrapped this in a that's in a quote. Okay, so we'll run that. That should work now. So what is the next bug or fixing? Money risk is not defined. Okay, I think we could run that again. And that goes through. Okay, so everything is working fine. You could see we have our loading our data frame loaded, inspecting our data frame to check the head of our data frame. So this is what the head looked like. We have Algeria, blah, 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 and all of that. Because that was the first 10 head that we were looking at. And we have 10 rows by 27 columns. We can try to add the shape. Remember, we can add the shape. There are also other things we can add. We renamed this successfully. It was successful. We're about to drop 11 column. It was successful. We targeted and all of that. Okay. So we'll go to the next class. Sorry, to the next method. After the last one we have here is create target. We could just check out what's the next. Okay, that's ml.visualize. Okay, let's see if that works as well. So I could just come down here and I'm gonna do ml.visualize. Okay, let's see what happens. It said string has no attribute value counts. Let's check what's happened there. And I'm just gonna check self.target dot value counts. So sure we spelled everything. I'm just gonna check something now. Let's check out something now. Okay. Just to be sure. It said the string doesn't have any object. There's no attributes. So we're gonna be very careful. That's terms of visualize. And so what we can do, mm, Okay. Let's check. Let's go up. Okay. I think this should be here. Okay, just to be sure. So what we can do is, so we cannot just change this now. We can say plot dot fi figure. First of all, let's say we have a fixed size of maybe 7 and 8. And we're going to say plot dot bar. And then we're going to pass in uh self so self dot target. And so let's run this time. Let's see what happens. What happens this time? Okay, it has one position. Bar has one positional argument, and it could be height. Mm, and okay, I'm trying to know because we can actually unpack the target. Let's say dot and run this and see what happens. It's not going to go down. Okay, it's okay. So could just come down here. What we're gonna do? We could pass. Because this is a small area, and suppose silver is equals to self dot target dot value counts. And then let's say we'll pass values. And then let's see what happens. It still doesn't want the values, and what we can do now is probably we can just silence that visualization. Then probably when we are back, we can always just kind of check out that, okay? So we'll comment that out. And then the next thing is our data preparation. Uh, we could check out our, I think we can still run this without, we can run this without, sorry. So how do we resolve that? So we can say data dot preparation. We need to leave that there. And hold on, we can just kind of scroll down. Okay. Of course, that's fine. It does that as we want. That works really well. And then we move to the next one. which is going to be splitting data. So we call that method, and then cat and column names, okay? So we're gonna come here, we'll say ml dot splitting data, ml dot cat and column, ml dot column. Then we run all of that. Everything works really well. You could see that here. Pre-processing for model, processing and column transformation. Successful, very, very successful. Just to be sure we are moving in the right direction. Then the next one is going to be load, train, and evaluate, okay? Load, train, and evaluate. So we're gonna come here. Also, we're gonna say ml.load load model, ml.train model, ml.evaluate model. Has an attribute saved model. Okay, I think I made a mistake. Was it just load? Okay, so I have load model of train model. We have evaluate. Just to be sure we're not missing out on something. Pre-processing and column transformation, has that been done? Then load. Does not actually save model. Um, and then, of course, we're gonna push in display ROC. Then display ROC cross validation and let's say ml dot display ROC, ml dot cross validation, ml dot tune model. Then we have get best params, new tuned prediction, get best params, new tuned predictions. Okay, and we're gonna have ml dot get best params. Okay, ml dot hotels. So after ML Newtoned prediction, Newtoned evaluation, tuned ROC. Yeah, we have how many methods? Save model, load model, predict probability. Uh, all right, so Maria object has no attribute saved model. So we go to load. Oh, we're having two clashes of so we can see loaded model. I think that's going to work now. No, we still need to correct it there. Okay, beautiful. Uh, that's fine. So this is our ROC curve for malaria risk prediction 0.99. That's perfect. Hyperparameter tuning is an invalid estimator. We have max depth of this. Okay, we're gonna fix that. Wow, so these are our mean test accuracies and all of that. Uh, we have loaded model. I'm gonna kind of correct this quickly, real quick now. I think the error, I just want to understand where that error is. Okay, so we have in our tuned model, so we'll go to our tuned. Best params. Okay, we can use model here. I'm gonna change that to model. And so here we're gonna change. I think we forgot an S here. This is how much these things can influence. Just an S. That's what we forgot. An S. It is changing everything. Just an S. Okay, so it's tuning, it's successful, and we still expect. You see how much an S can cost. So it's performing, it's tuning. So we let our model tune. Okay. It tuned. It was successful at tuning. But then best params. Okay, I guess we forgot an underscore. Get best params. Mm, get best params. We forgot an underscore. And we could just run that. We could run that again. We forgot an underscore. Okay, so yeah, that is how it works. Okay, okay, so we check what is the issue. And it's saying the matplotlib has no attribute PLT. Where did we get it wrong? Tuned ROC. You know what? We'll go back to our tuned ROC. Plot dot. Oh, we made a mistake here. So that plot. And we're going to run it again. Just to be sure there is no issues. Um, okay, we're definitely going to run that. It's performing hyperparameter tuning. We need to make sure we debug. So that is why it's always important to run your code within cells. Because when you run it within cells, the ones that has already gone, you wouldn't have to waste so much time. It's just basically to do that. But just because of the sake of this video, I thought it twice, to have this kind of session, where I'm definitely going to show a lot of insights that are quite very important for beginners. Okay, so that's how it runs. Of course, we'll have that running. It's tuning hyperparameters to get the best estimator for us. If we kind of, okay, and gonna let it load. Okay, what's that? It said it expected string bytes or parts like object, and that's in loaded model. Okay, so that's just going to be like so what we're going to just do now is just kind of to wrap it with a part. Uh, for example, we could just put parts, 5 parts and all of that. Do you understand? So I could just correct that. Oh, so guys, that is just that. You're gonna see like after we tuned it, we displayed our model, we had everything, saved successfully. And so I'm just gonna kind of leave you here with this. Probably in our next session, of course, we are going to have, kind of much more advanced. I don't really want this video to be so long. Of course, yeah, it is, but everything here has already been well explained. This is everything you need, to kind of get started in object-oriented programming using in machine learning. So this is kind of a real-time practical insight of how we apply methods, passing some kind of, it takes in some attributes and all of that. We use the self keyword to define terms if we want to, kind of write it in another stance. We use story self. So this is, you just need to work. You need to get your hands dirty, kind of practice so many of these exercises. I'm just gonna leave this for you in a comment, uh, more like in a comment, for you to basically perform, some kind of, some practice, okay? I've just kind of uncommented that for you. And I'm going to just kind of run it one more last time for you to, kind of basically get the very, 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 very best out of it, okay? And in some of our next videos, we're going to also be looking at some kind of pandas, methods, functions, and all of that, These are also important metrics for anybody that finds, programming in Python very, very interesting. And so I want to kind of put it to you that you really can do so many, 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 many marvelous things, particularly when you start programming in Python, machine learning, and all of that. You can build libraries from scratch using some frameworks in other languages, but you're definitely not going to do all these things if you don't understand uh, how the computer operates and how it works and all of that. So as much as you're learning, you also need to make sure you expand your insights, kind of look around, network with people, collaborate, and you see yourself doing some things, very, very, very magnificent. So this is our model. It has already been saved successfully. And I'm going to say a very big thank you to each and every one of you, particularly for staying up to this particular part of this video. Uh, I want to really, really, really kind of appreciate. The link for this video is definitely going to be dropped on my Git repository. Of course, that's you can always get it if you need some kind of access to this code. Of course, definitely going to have it there. So, thank you. Other than that, thank you very much for this session, and see you on the next one. Bye-bye.